Hey, this is Mr. Warden. This is a key for geometry exit ticket 22.2, week 22, day 2. And we'll skip down here to remind you of some key information. Remind you that if a line is perpendicular to a plane, then it is also perpendicular, meaning it makes right angles, with any line that lies on the plane and intersects with its foot, the point where it intersects the plane. Then theorem 40 is basically the flippity-do, or the reverse of that definition. If a line is perpendicular to two distinct lines that lie on a plane and that pass through its foot, then it is perpendicular to that plane. So this line is defined as perpendicular to BF and CF, and therefore AF is perpendicular to this plane. BF and CF are distinct lines that lie on plane M. So let's take a look at our proofs. So we're going to prove that AB is congruent to CD. And a general strategy, after we look at things, we got PB is perpendicular to plane M, and we know that APB, this angle up here, is congruent to angle CPB. So we got these angles. It'll be useful for proving AB and CB are congruent to prove that triangle ABP and triangle CBP are congruent. And I think we have what we need to do that. So let's start. So we have some givens. We know PB is perpendicular to plane M. We know that this angle APB is congruent to angle CPB. And now we can add that PB is congruent to itself because of reflexive. Then we can, once we know that, we can say that triangle APB is congruent. APB is congruent to triangle CPB by the angle side angle postulate. This angle is congruent to this angle. These two angles are right angles because PB is perpendicular to M. I think I might need an extra line, but that's okay. We'll deal with that in a second. And PB is congruent to itself. So angle, side angle will allow us to prove that those triangles are congruent. And once we have that, AB is going to be congruent to CB by corresponding parts of congruent triangles are congruent. And then finally, I did say that we might need a fourth line here. I did say maybe only need 3 statements, but I think maybe a fourth line after the givens is necessary that states that angles PBA and PBC are congruent, are right angles and therefore congruent. So let's go ahead and label some of the stuff that was given to us. So this tells us that this is true. This is the first given, okay? And then the second given tells us here that this is true, that these angles are congruent. Okay, and then we can say that PB is congruent to itself here by the reflexive property. And then we can say that these two triangles are congruent by ASA. Okay, and once we've done that, we can establish that AB is congruent to CB, okay, by Kappa-Kadika. And I'm leaning towards thinking maybe we needed a fourth line in there somewhere to communicate clearly that because PB is perpendicular to plane M, that by definition of that, PB is perpendicular to AB and CB as well. Okay, so let's keep going. Let's go into 4B, and 4B is asking us to prove that T is the midpoint of AB and CD. Okay, so let's see what we've got. We've got some givens. We know that AB and CD lie on the plane S. That's plane S. And we know that PT here is perpendicular to plane S. And then we also know that PC and PD are congruent. That's given. And PA and PB are congruent. That's also given. So let's see what we can work out beyond that. Well, I'm going to go ahead and add in that line. PTA, PTB, PTC, and PTD are all right angles because a line perpendicular to a plane is perpendicular to any lines that lie on that plane and intersect with its foot. Okay, now because they're all right angles, angle PTA, PTB, PTC, and PTD are congruent because right angles are congruent. And now PT is congruent to itself by reflexive. In this case, maybe I didn't need this. We just need that those are right angles because that defines PTA and PTB as right triangles and PTC and PTD as right triangles. So I may come back and revise that in a second. But because of that, we can prove that triangle PTA and PTB are congruent and PTC and PTD are congruent, all by the hypotenuse leg postulate. PT being congruent to itself, and these two sides are congruent. Again, PT is congruent to itself, and PC and PD are congruent. So a hypotenuse leg comes into play. Let me scroll down a little bit so we can see what I'm doing. And that tells us that AT and BT are congruent by Kappa-Kadika, and CT and DT are congruent by Kappa-Kadika. And finally, T is the midpoint of AB and also of CD by definition of a midpoint. So I'm going to go ahead, I'm going to change this to, I'm going to change this a little bit. I think probably the better way to do this is say triangles, all of these triangles are right triangles because that's actually more to the point. Okay, and that'll be definition of a right triangle. They have a right angle in each of them. All right, and here. All right, and so there we have it. I'm going to go ahead and label the stuff that we have real quick. So we know that this and this are right, and that this is right, and this is right. I know that's kind of ugly and messy, but that's what it is. We know that that this and this are congruent. We know that this and this are congruent. And let's see. We know that this is congruent to itself. And with all of that information, because these are right triangles and they have a leg and a hypotenuse congruency and a leg and a hypotenuse congruency, then these two side triangles and these two side triangles are congruent by hypotenuse leg. Okay, and once we have that, then we can say that this is congruent to this, and also this is congruent to this. You can't really see it, but these segments on either side of T are congruent, and these segments on either side of T are congruent, and therefore T is the midpoint of A, B, and CD by definition of a midpoint. All right, I hope that has been helpful to you.